Okay, hello. So I guess people will pop in and pop out as they need to, but like I said, I'm going to go over the test review tonight. It's the paper one. Just a few things. Your test two will open at midnight tonight, and it will be open through Sunday at 11:59. You'll have 2 hours to complete it. Once you complete it, I will go in and I will look at each question and score it as necessary. So your score may change based on how you answer each of the questions. So make sure you're paying attention to that. So I'm going to go over the paper review. I'm going to work out each question. If you don't attend tonight's live session, then I will post this on Ivy Learn so you can have access to it then. So here we go. All right. Okay, a little technical difficulty. Let's get the right screen, share screen. I don't know why it's not sharing. Now let's try this again. Okay. So sharing screen 2. Okay, so let's go ahead and get started. So question 1 says the average price of Easter dinner last year was $49.48. This year it's predicted to be $52.23. Use the absolute relative change and write a sentence or two to describe the change. Okay, so remember, when we talk about absolute change, that's the actual change. So to find the absolute change, that's where we do the new minus the old. So in this case, our new was 52.23. Our old is 49.48. So when we do new minus old, we do 52.23 minus 49.48. And when we do that subtraction, I get out my handy dandy calculator here. So 52.23 minus 49.48 will give us $2.75. So that's the absolute change. So then to find the relative change, that's where we do new minus old divided by old. So in this case, it'd be 275 divided by 49.48, which gives us 275 divided by 49.48, which gives us, so that's 0.056, so that's 5.6%. So then when you look at writing this in a sentence, you would describe that the average price of the dinner increased by $2.75, which is a relative change of 5.6%. Okay. So for question number 2, very similar setup. The US has 2,250 Olympic medals. Russia has 1865. Write a sentence that compares Russia to the US using relative change. Okay. So we're comparing Russia to the US. So here, when it says compare Russia to the US, Russia is going to act as our new. US is going to act as our old. So to find the relative change, we do new minus old divided by old. So it would be 1865 minus 2250 divided by 2250. So when we do 1865 minus 2250, we get negative 385. So when we do 385 divided by 2250, we get negative 0.171, so negative 17.1%. So then we would say something such that Russia has 17.1% less metals than the United States. That's what we're looking for here. All right, question 3. So for question 3, you're told that a new book costs 27% more than a used book. If the used book costs $90, how much does the new book cost? Okay. So in this case, you're told 27% more than a used book. So we know how much the used book cost. So in this case, we're going to take, because it says 27% more than, we're going to do 27% plus 100% to get 127%. So the new book would be 127% of $90. So in this case, it'd be 1.27 times 90, which is equal to 114.30. So the new book would cost 114.30. Now, if you wanted to do that using a proportion, the way that we would set that up would be, we can say that the new book compared to the old book, or not the old book, a used book. Well, we know that we don't know how much the new book costs. We know the used book costs 90. We know the new book is 127 over 100. So then we would cross multiply. So we do 127 times 90. That gives us 11,430 equals 100x. So then when we divide both sides by 100, we get the same answer. So we get 114.30 equals x. So that's how much the new book costs. Okay. Number 4, this question was confusing for a lot of people on the homework. So I received the bill for $26.75 after the tax, assuming the tax is 7%. What's the menu price of this item? Okay, so keep in mind, again, remember that this represents 107%. Because keep in mind that you pay 100% of the full price plus the 7% sales tax. So if I were to set this up, it would be 107% of x equals $26.75. So it'd be 1.07 times x equals $26.75. So then I divide both sides by 1.07, and we get x is equal to $26.75 divided by 1.07, which is $25. Now, if I set this up using a proportion, again, we know that our, let's see, our $26.75 represents our 107%, and we want to find our 100%. So then we get 107x is equal to 2,675. So when I divide by 107, we get x is equal to 25. So therefore, the menu price of the item is $25. Okay, number 5. So number 5 tells us the Kokomo Ivy Tech had 5,800 students enrolled in fall of 2012. This is down 10.7% from fall of 2011. About how many students must have been enrolled in fall of 2011. Okay, so here we're comparing the enrollment of fall 2011 to the enrollment of fall 2012. All right, so we don't know the enrollment for fall 2011. That's what we're trying to calculate. We know the enrollment for fall 2012 is 5,800. So We know that the fall 2012 enrollment was a decrease. So if we use this as our 100%, we do 100 minus 10.7 to get 89.3. So when I cross multiply, we get 100x is equal to 89.3 times 5,800, which is 51,7940. So then we divide by 100, and we get that x is equal to approximately 5,179 students. We have to put the approximately because we do get a decimal, but we want to round. We don't have 4/10 of a person. Okay. Question 6, the club charges a $10 entrance fee, and then charges $4.25 per drink. Set up the linear model representing the cost of drinking at this club. Okay. So in this case, whenever it says set up a linear model, you want to think y equals mx plus b. Y and x are going to stay the same, nothing changes there. Our m and our b is going to be different depending. So right off the bat, you pay $10 to get into the club. So that's our b. Anytime it says anything per, that usually represents our m, that's our slope. So this linear model would be y equals 425x plus 10. $10 to get in, $4.25 per drink. So what are our variables represent? Which is independent, which is dependent. So our x represents the number of drinks, and that's dependent. Our y represents our total cost, and that's independent. So then the next thing is how much drinking can you do for $25? Okay, so this we're going to put in place of y. So then we would say that 25 equals 425x plus 10. So we solve this for x. So we subtract 10 from both sides. We get 15 is equal to 425x. Then when I divide by 4.25, 15 divided by 4.25, you get some weird decimal. You get 3.529, yada, yada, yada. Well, keep in mind that you're not going to be able to go and buy 0.529 of a drink, so we're going to round this. Well, here's the thing. If I round up, if I try to round up, the problem is that if I try to buy 4 drinks, that's going to put me over. So in this case, we have to round down. So this would be approximately equal to 3. So 3 drinks. So make sure you're paying attention to those rounding rules. Okay, any questions? Okay, so now we're going to move on to page 2. I think there's 4 pages here. Yep. All right, so question 7. You spend $10,000 to start an alpaca farm. You can sell each for $200. Set up a linear model. Again, boom, linear model. Y equals mx plus b. 10,000, that's your starting cost. That's your b, $200. That's your m. Now, here it says set up a linear model that calculates your profit or a loss. So if that's the case, your starting cost is going to be negative and your slope is going to be positive because the more that you sell, the more you'll make up your starting cost. So your linear model here would be y equals 200x minus 10,000. So how much profit or loss would you have after selling 24 alpacas? Well, this is going to be our x. So y equals 200 times 24 minus 10,000. So So this would be 4,800 minus 10,000, which is negative $5,200. So this represents a $5,200 loss. Okay, so now the next question says, how many do you have to sell to break even? Well, remember, breaking even is when y is equal to 0. So this would be 0 equals 200x minus 10,000. So we add 10,000 to both sides. I'm going to move this over here. So we get 10,000 is equal to 200x. We divide both sides by 200, and we get 500. So this means that we would have to sell 500 alpacas in order to break even. Okay. So question 8, now we're going back to enrollment. So Ivy Tech and Gary had an enrollment of 3,210 students in 2000. They had an enrollment of 5,209 students in 2010. Find the average rate of change. So find the average rate of change. This is where we have to find the slope. So M equals, this is where we're going to use new minus old. So we do new minus old in terms of the number, new minus old in terms of the years, because time is always in the denominator. So this would be 5,209 minus 3,210 divided by 2010 minus 2000. So 5,209 minus 3,210 is 5,209 minus 3,210, not divided by, is 1,999 divided by 10. So it's approximately 199.9 students. Okay, so that's an increase. Now it says set up the linear model. Okay, so in this case, our B, that would be our starting point. So we started at 3,210 students in the year 2000. So again, linear model, y equals mx plus b. So y equals 199.9x plus 3,210. Okay, question C. Part C says predict the enrollment for 2014. Do you think this number will be accurate? Explain. Okay. So 2014, that's 14 years after 2000. So if I do 2014 minus 2000, that means we're going to use 14 for x. So if I plug 14 into my model, 199.9 times 14 plus 3,210. So 199.9 times 14 is 2798.6 plus 3,210. That gives us 6,008.60. So approximately 6,009 students. Now, again, do you think this number will be accurate? It depends. It's 4 years past the 2010. It could potentially be accurate if this trend continues. Now, if it starts declining in the number of students, then the number may not be so accurate. So be careful with that. Again, remember that you want to keep in mind that you want to stay within the scope of the model. All right, question 9. So for question 9, again, here's that information. This is made based on head counts at Gary Ivy Tech from 1992, 2011. They've given you this nice equation. They've given you a trend line. They've given you the actual numbers. So it says use the trend line to estimate the enrollment for 2004. Okay. Well, because it says use the trend line equation for the number 2004, because of this model, because of how it looks, notice we've got this big number over here, this 353,194. So because of that, we're going to plug 2004 in place of x. So here we would say y equals 178.09 times 2004 minus 353,194. So 178.09 times 2004, that's 356,892.36 minus 353,194. So 3698.36. So approximately 3,698 students. Okay, so how does this value actually compare with the value for 2004? So notice that this is the estimate. This is the actual. So the actual value is less than the estimate. Okay, now we look at the slope. So when I look at this slope, it says interpret the meaning. So what does this number mean? What does this 178.09 mean? Well, this tells us that basically that the number of students increases by 178 each year. That's what that tells us. Okay, so then the next one says, the last question, part D, says, should we use this model to predict headcounts for 2020? Why or why not? Well, here, 2020, that's 10 years beyond, so no. Because 2020 falls outside the scope of the model. Okay, so that's number 9. And like I said, this is all being recorded as of right now, so you will be able to access this later if you didn't before. All right, so let us move on to question number 10 here in just a second. Okay. All right, so question 10. Question 10 says that Professor Ivy starts a Twitter account with 100 students. The number doubles every month. How would you express this as an exponential? Okay, so boom, exponential. Anytime we see anything that says double, half, triples, anything like that, it automatically makes it an exponential. So you're going to follow the exponential model. So remember the exponential model. So we know that our amount, our A, is equal to, how much did we start with? We started with 100. What's our growth factor? It doubles, so that's 2. So 2 to the t power. So that's the model that we would write for this example. So then how many followers would she have after 4 months? So this is going to be our t. So the amount would be 100 times 2 to the 4th power. So that'd be 100 times 16. So that's 1,600 followers. Okay. So now the question says, how many months would it take to reach 1 million followers? Okay. So there's a few ways that you can approach this, depending on how you look at it. One of the ways that you could approach this gets kind of ugly with logs, so we're not really going to mess with that one. Instead, we're going to look at it in comparison to, if I do 1 million followers equals 100 times 2 to the t power. Well, if I divide that by 100, we end up with 10,000 equals 2 to the t power. So here we can guess and check. What power of 2 is 10,000? So, well, we know that 2 to the 4th is 16, so we can start looking at, okay, so, let's try 10. So if I try 2 to the 10th power, that's 1024. Nope. Let's try 100. 2 to the 100th power, nope, too big. Let's try 20th. Well, 2 to the 20th is 1,048,000. That's still too big. So let's try 2 to the 15th. 32,768. That's pretty close. So let's try 2 to the 18th power. 262. Let's try 2 to the 19th power. Oops, back up. I went 10,000, so I went too far. So let's try 2 to the 12th. 2 to the 13th. 2 to the 14th power. So notice that my calculator's not going to show up unless I turn the light out. Okay. Nope, it's still not going to show up, sorry. So notice that if you try guess and check, the answer is going to be between 13 and 14 months. So T is between 13 and 14 months. And you can check that here. Okay. All right, number 11, the weight of cell phones has been decreasing 20% each year since 1983. Based on this information, if a cell phone in 1983 weighed 2.5 pounds, how much would a cell phone weigh in 1984? Okay, so we have to set up our model. So our model, in this case, would be A equals, we started at 2.5 times. This is a decrease. So because it's a decrease, that's a decay. So it's going to be 1 minus 0.20, 20% to the t power. So this would be 2.5 times 0.8 to the t power. So then how much would a phone weigh in 1984? Well, the year 1984 here represents 1 year since 1983. So this would be 2.5 times 0.8 to the first power. So that would be 2 pounds. So according to this model, a phone would weigh 2 pounds in 1984. So how much would a phone weigh in 2020? Well, if I do 2020 minus 1983, that is 37 years. So we're going to use t equals 37. So A equals 2.5 times 0.80 to the 37th power. Times 2.5. So that gives you this really big decimal, 6.49 times 10 to the negative 4th power. That's a really, really lightweight phone. So there you go. Okay. So 10 to the negative 4th power, that's again really, really small, so we're not even going to worry about writing that out as a decimal. Okay, number 12. So number 12 says a park ranger creates a table for different plant growths over a 4-month period. Which of the plants has an exponential growth pattern? Okay. So to figure out which one has an exponential, that's where we have to look at the change over a period of time. And we're looking for which one has the same percent change over time. So this is where we're going to do new divided by old for each of these. So if I do 5.5 divided by 4, we get 1.375. If I do 7 divided by 5.5, we get 1.27. So automatically, because those are different, this is a no. So then I come over here and do the same thing. So if I do 5 divided by 4, we get 1.25. If I do 7 divided by 5, we get 1.4. Automatic, those are different. So this is a no. Okay, so here, same idea. So if I do 4.2 divided by 2, that's 2.1. If I do 8.82 divided by 4.2, oh, we get 2.1. And if I do 18.52 divided by 8.82, we get 2.1. Yay, guess what? There's our winner. So the plant that has the exponential growth pattern is the kudzu. Okay. All right, question number 13 is talking about credit cards. So you purchased $300 worth of electronics on your credit card. Grace period is passed, 15% APR, minimum payment is 2% balance determined. All this fun information. Okay, so in month 1, your carryover balance was $300. With your APR, this 15% is 0.15 divided by 12. The APR represents the annual percentage rate, how much you pay in a year. But because your monthly payments are divided up, we have to divide that rate by 12. So to calculate the finance charge, we would do 300 times 0.15 divided by 12. So this means that your finance charge is going to be $3.75. So then your new balance would be these two added together, so it'd be $303.75. So then your minimum monthly payment is 2% of that new balance. So it'd be $303.75 times 0.02. Which is 608. Everything always gets rounded up. So now to calculate the carryover balance, we subtract these two. So if I do 300, actually we subtract these two. So if I do 303.75 minus 608, we get a carryover balance to month 2 of $297.67. So we do the same thing again. So I do 0.05 divided by 12 times this 297.67. So this time we get a finance charge of $372. So when I add that, 372 to the 297.67, we get now 301.39. So then the minimum payment would be 2% of this, which again, this time would be $6.03. So then when I subtract these, so 301.39 minus 603, we get a carryover balance of $295.36. Okay. All right, question 14. Describe the difference between simple and compound interest. Simple interest is interest that's calculated one time. It's calculated at the beginning and it goes for the life of the loan. Compound interest is interest that is calculated on top of interest. It's calculated over many periods throughout the life of the loan or the life of the investments. That's the big difference between those two. Okay. Hey, looky there, last page. All right, so question 15. All right, your wealthy grandmother deposited $1,000 for you in a savings account that earns 4%, and you can have the money when you graduate in 2 years. How much money will you receive if interest is compounded annually? Okay. In your book, you should have this yellow sheet. It's towards the middle. It's after all the sections. So this yellow sheet is a formula sheet that you can use. You're not going to use the front part of this quite yet. This is for this last section. But if you flip it over to the back, if you look at the very bottom, all these formulas you can use on your test. So you have all of this available to you to use. So if I come over here and it says that they deposit $100 in a savings account that earns 4%, and you can have the money when you graduate in 2 years, how much money will you receive if the interest is compounded annually? So if it's compounded annually, you're going to use this formula. Balance equals principal times 1 plus the rate times the time. So the balance would be equal to $1,000 times 1 plus. Now this we're going to write as a decimal, 0.04 to the second power, because we're doing that over 2 years. So this would be 1.04 squared times 1,000, which means at the end of that 2-year period, you're going to have $1,081.60 in the account. Wonderful. Now, for part B, it says that it is compounded monthly. Well, because it's compounded monthly, that's where we're going to use the second formula, because it's compounded 12 times a year instead of just once a year. So in this case, the balance would be equal to 1,000 times 1 plus 0.04 divided by 12 to the 2 times 12 power. Now, when I go to punch this in the calculator, I would start with the division and then work my way out of the parentheses. So I would do 0.04 divided by 12 plus 1 to the 24th power times 1,000. And you get 1,083.14. So notice that, did we really make that much more interest with it being compounded monthly? No, not really, like $1.50 more, so not that big of a deal. Okay. All right, 16. If I invest $100 per month in a 401k at 1.5% APR compounded monthly for 20 years, what would I enter to Excel to determine the balance at the end of the 20 years? Okay. So this is a retirement question. So because this is a retirement question and they are asking us to use Excel, we're going to use future values. So we're going to use FV. That's the function that we're going to use. So what would I enter into Excel? Equals FV parentheses. The monthly interest rate is going to be 0.015 divided by 12, comma. And notice it says monthly for 20 years. So 12 times 20. And then I'm going to say negative 100. You have to put that negative in front of that 100 to make sure that the formula works right. So this is what you would enter into Excel. Okay. All right, so question 18, what would I type into Excel to find out the mortgage payment for a 30-year, $125,000 loan at 4.5%? Notice that it says payment, automatic. So because it says payment, this is a PMT function. So in Excel, we would say equals PMT. The monthly interest rate is 0.045 divided by 12, 30 years, so that's 12 times 30. And then the amount, negative 125,000. Again, the payment function comes from the formula sheet, equals PMT. Okay, so according to Excel, how much would my payment be? Okay. So if I bring my Excel sheet over here, which I've done, I did a few things earlier. So I'm just going to go to a cell and I'm going to type in equals PMT 0.045 divided by 12, comma 12 times 30, comma negative 125,000. We get a payment of $633.36. $633.36. That's what I'm going to put here. $633.36. Okay. Now, how much will be paid on interest over the life of the loan? Okay. So to calculate that, again, I could go back to Excel. Excel would probably be the easiest to use here. So in this case, if I wanted to calculate how much I would pay over the life of the loan, I would take my 633.36 times 12 times 30 to get a total of $228,009.60. So $228,009.60 minus my original $125,000 loan. So equals F2 minus 125,000. That means that we're going to pay approximately $103,009.60 in interest over the life of the loan. Wonderful. Okay. So last question. Question 19 says, Johnny currently pays $750 in rent, but wants to spend his money to buy a house instead. He determines that monthly insurance and taxes will be $150 and he has no other debts. Johnny can get a 30-year mortgage with 4.5% APR. What would he need to type into Excel to find out how large of a mortgage that he can afford? Okay. Well, to calculate that, we have to think about how much mortgage is affordable. Well, in this case, if he can afford $750 in rent, but he's going to pay $150 in insurance and taxes, and he has no other debt, the $750 already includes that. So we have to subtract that out. So we have to do $750 minus $150 to get that he can afford a $600 a month mortgage payment. So if he can afford $600 a month mortgage payment, because they want us to know how large of a mortgage he can afford, this is a PV, this is a present value. So on your formula sheet, we're going to use this equals PV. So into Excel, we would type in equals PV time, or in parentheses, 0.045 divided by 12, comma. It's a 30-year mortgage. So it'd be 12 times 30. And then our monthly payment, well, it'd be negative 600. So we would type that, that is what we would type into Excel to help us answer that question. Okay. All right, so this concludes the test review. To those that are here, does anyone have any questions about said test review?
Yeah, I do.
What's up?
Okay, so how do you know when to use, like you said it for one of them, how do you know when to use the PMT and the PV functions? Like what tells you?
Okay, so in the question, so if the question says calculate a monthly payment of any kind, car loan, mortgage, anything like that, always use the PMT function. Because that's what PMT stands for. It stands for payment. So if they're asking you to calculate a monthly payment, you would use that function.
Okay.
PV, remember that PV represents present value. So PV is where you would want to know, okay, if I can make this monthly payment every month over a period of time at this interest rate, what can I afford? So for example here, PV was used in this example to calculate how much of a mortgage can he afford.
Okay.
So if it says how much of a mortgage, how much can you borrow, how much of a car loan, anything like that, you use present, or yes, PV, present value.
Okay.
FV represents future value. So future value is looking to how much is this all going to cost me in the future? So if the question says, what would the balance be at the end of a certain period, or how much will I pay all together or anything like that, then you would use future value to calculate that.
Okay.
Does that help answer your question?
It does. It does.
All right, great.
I'm trying to figure out what other questions I had. Um, oh, okay. So is there two reviews that we have to do that's due on the 19th? Which one is due on the 19th, or did that date change?
So the 19th is the online review.
Okay.
This is the one that was due for the 080 class tonight.
Okay.
So you would submit that under the Unit 2 Skills and Resource Quiz. But this is the paper review. So the one that's due on the 19th is the online review that's in the outcomes.
Okay.
All right?
Okay. I think I got this one, this side pretty down packed. I could really understand this one. I think the last homework assignment I really was struggling with. Like I messaged you about the number 4. I couldn't really understand that one.
So on that number 4, on that homework assignment, they wanted you to create what's called an amortization table. So in Excel, I did an example of that. So when you create a table like that, what you're doing is you're looking at, okay, if I start with this balance in month 1 and I make this payment, I make the same payment every month. How much of my payment am I paying towards interest? How much of my payment am I paying towards the principal? So what I did here is that I created a table by doing 5 columns: the month, the balance, the payment, the interest, and the principal. So in that question, it started off with a $100,000 mortgage. So what I did was I used the payment function to calculate how much would the monthly payment be based on the terms of the mortgage. And you're able to see my screen, correct?
Yeah, I could see it.
Okay. So then to calculate the monthly interest, what we did was we took that 0.06 divided by 12 and multiplied it by the actual balance to calculate how much of my payment is going towards interest that month.
Okay.
Then what I did was to calculate how much of the payment goes towards the principal, the balance, I just subtracted these 2 columns. And that's where that 99.55 comes in.
Oh, okay.
Then I did 100,000 minus 99.55 to get this next column.
Okay.
Now, I wasn't going to type out that formula 360 times.
Right.
Because that's 30 years, right? So
Right.
what I did was, and it's kind of long for this, but I went to month 2 and I did 1 plus 1. Then I came down here, right or left click the lower right hand corner and drag this, copy this formula all the way down to 360.
Okay.
Then I did the same thing for each of these columns. I clicked each cell, left click the lower right hand corner, drag the formulas all the way down every time.
Okay.
So that's how you would create an amortization table to help you answer that question.
Okay. Yeah, I think that's probably what I was struggling with. I didn't know how to create the table. Now in Excel, sometimes I type in the values or whatever, and sometimes it be in red. If it's in red, do that mean it's wrong?
Oh, like the cells, like C11, D11?
Right.
No. So Excel has a built-in way to identify different cells, and that's where they color code them.
Oh, okay.
So it's not wrong.
Okay. Okay. I think one more thing I was struggling with on the review, I think it was dealing with the making dealing with the trend lines and the slope, I think it was. I don't have my paper on me.
So you're probably looking at question 9.
Yeah, that's where I came in at when you were starting.
This one?
Yeah.
Okay. So with this one, when I look at this equation, because they give me this really large number over here,
Mhm.
they're going to have me plug in the year for X. So instead of doing 2004 minus 1992, I'm just going to plug in 2004 in place of X. And that's what I did here.
Oh, see, I did that at first, but I think I changed it. And when I did the difference between 1992 and 2004.
Ah, okay. So if you were to go through and do that, so I know that's 12. If I plug 12 into here, that's going to give me a really big negative number.
Exactly.
If
And
you
that's what
look at the actual, it's pretty close to 3,500. So if you do that and you see that this final answer is way off, go back and try it the other way.
okay.
That would be
Yeah, so
my
that
recommendation.
is what I did. I got a negative number.
Yeah, so then you would go back and just plug in the actual year instead of the difference between the two.
Okay. Okay.
Does that help answer your question there?
Yes, it does.
All right, great.
Okay. Can you go over 8 for me?
Sure. So for number 8, when it says enrollment here, that's where we're going to use the slope formula. So the slope formula is this one. So I'm going to find the change and the number of students compared to the change in the years. So if I look at how many students did it increase or decrease by from 2010 to 2000, well, 1,999.
Okay.
And that's over a 10-year period. So when I do 1999 divided by 10, that's 199.9 students. So this tells us that the average enrollment increased by 199.9 students per year. That's our M.
Okay.
Anytime it says linear model, we automatically think y equals mx plus b.
Right.
So y equals, we know our slope is 199.9x plus, where did we start at? We started at 3210 in year 2000. So we put 3210 as our starting point.
Okay.
So that's what you would do here for part B.
Okay.
Now for part C, because I did subtract the years and the slope, I have to subtract the years here to figure out what value to use for x. So here we use 2014 minus 2000 to get x is equal to 14.
Okay.
So then when I plug 14 in place of x, we get a value of 6,008.6, so approximately 6,009 students. And again, do we think this number will be accurate? Depends. It's outside the scope of the model, so it could or cannot be. It depends on the trend.
Right. Okay.
So that's how you would answer question 8.
Okay.
Does that help answer your question?
Yes, it does.
Okay, great. All right. Do you have any other questions for me?
I don't think so. So we have a test coming up, right?
So your test is going to be available at midnight tonight. It has to be completed by Sunday at 11:59. You get 2 hours to do it. It's one of those that once you start it, you have to finish it in the same setting.
Right.
So like when you sit down to do it, you want to give yourself 2 hours, interruption free if possible. Have your scrap paper, your formula sheet, and your calculator ready to go whenever you're ready to start.
You won't believe what happened to me.
Oh, no.
My calculator broke. So I have to go buy another one. And I was having some calculator problems with one of these assignments. I can't name which one because I don't know off the top of my head. But I was having calculator problems and I didn't know how to do it. I tried to search the internet to give me the right answer, but it didn't.
So if you don't have a calculator, one of the things that you could do is you could type in Desmos, DESMOS,
Mhm.
scientific calculator.
Okay.
So if you type that in the Google, that will pull up the Desmos scientific calculator. It's an online calculator that you'll be able to use to help you answer all these questions.
Oh, okay.
So if you
Okay.
weren't able to get out and buy a new calculator, Desmos scientific calculator will do the trick for you.
Okay. I'm gonna write that down because I probably won't remember that. Desmos scientific calculator.
Yep, DESMOS, Desmos scientific calculator.
Okay. Thank you.
You're welcome, no problem.
All right. That's all the questions I have for you.
All right, wonderful, sounds good.